Okay, thank you to all our presenters. Very interesting works. And now I want to know if people that is listening us have any questions for them, or I can also begin by asking some questions to Juan Luis Gonzalez. Maybe I can start asking about his paper, Forget About the LIDAR Self-Supervised Depth Estimators with Net Probability Volumes. What are the data structures that you use to represent the input of these type of models?
Give me a second.
Sure. So I was wondering what are the data structures that you use to represent the input for this type of models? I'm not that familiar, or maybe other people around is not that familiar with this type of models. So can you elaborate a little bit?
So this problem is monocular depth estimation, which is estimating the 3D geometries from a single image. So the input of the network is just a single image, and the output is a disparity map, which is the same or very similar to an inverse depth map.
And is this map like also image, or it's another type of?
The input is just an RGB image, and the output is a 2D disparity map. I don't know if that answers the question.
Yeah, thank you. Okay, if there is no other question, I'm gonna check. So Salva, maybe about your work of model misspecification in multiple week supervision. Um, can you elaborate a little bit more on what does it mean to have a structure over a specification? What is the problem with that you mentioned, or the errors due to that?
Yeah, so when we have like over specification, what we mean by that is that we are specific modeling too many dependencies between labeling functions, between sources of weak supervision. And when we are modeling too many of them, we denote it as overspecification of the structure of the probability of the graphical model. And yeah, so what we found was that seemed to be causing quite some errors in downstream performance of a neural network, which could be due to sample complexity, because you are specifying so many dependencies. That means also lots of parameters that the model needs to learn, and that could lead to the deterioration of the performance.
Thank you, Salva. Okay, for presentation number 3 from Gustavo, an evaluation metric for generative models using hierarchical clustering. Gustavo, I wonder how the dendrograms are created. Are they inputs, or you generate that or along the model?
Okay, so they're part of the metric pipeline. Basically, like in terms of implementation, the class receives 2 sets of data, some sample of the training data and some generated data. Then the dendrograms are built using hierarchical clustering, like very simple implementation, single linkage hierarchical clustering. And after having this dendrograms, we compute the similarity between them. So it's just a usual dendrogram using scikit-learn inside the whole pipeline.
Thank you, Gustavo. I'm gonna double check again if we don't have any other question around that I'm missing. I guess there's a question in the chat in the RIPS webpage, but I'm not sure who they are addressing to. Can you please explain about the cost function of this model? If by that Russia that can have more precision on that, we can address this question. In the meanwhile, we can ask Ariel about his work on generative adversarial stack autoencoders. What do you think was the most challenging part of this work, Ariel?
I think just like any other generative adversarial models, there is always a difficulty in training this particular type of model because they often lead to mod collapse. And so that's a big problem that I don't think we have a solution for just yet. But the proposed approach, it actually helps a little bit on that because the loss, the reconstruction loss for the autoencoder model usually is a lot lower than training in an empirical manner.
I see. Thank you. So I guess, oh yeah, about the generative adversarial stack autoencoders. Videt also ask if you can explain about the cost function of this model.
Yeah, the cost function is simply a combination of the reconstruction loss and for the autoencoder, as well as the classification loss for the classifier, which essentially is just the discriminator. There is a cost function for every shallow autoencoder. And finally, when you are done training all the smaller models and put them all together, you also have the same loss for the final model. So essentially, just a combination of the reconstruction loss and the classification loss.
Thank you, Ariel. I'm going to double check if there's no other, I guess, yeah, no more questions. So thank you very much to all our presenters. And thanks for making the workshop happening, through sending your work. We're very proud of you. And for all the people that is listening to us, we will come back in some minutes for our next sessions.